Hello students and a very good morning to you. Students, today we are going to start chapter 12 of class 8 science, that is chemical effects of electric current. In this chapter we will study about electric current, conductors and insulators, chemical effects of electric current, that is electrolysis, applications of electrolysis and applications of electroplating. So first of all, we will study about electric current. This topic you have studied in your previous classes also, because we know students that electricity is very important for us. It plays a very vital role in our lives. Means everything that we use at our home, we use electric current, we use electricity in that. We know that electricity light our houses. By using electricity we can cook food, we watch televisions, we run computers, we run air conditioners, we use heaters. So many things are there in which we use electric current. So what is this electric current? We have studied that the flow of electric charges through a conducting material is called electric current. Means when through a conducting material electric charges flows, that flow of electric current is called a flow of electric charges is called electric current. We know that the SI unit of electric current is ampere, and the amount of electric current passing through any device is measured by a meter. Next topic is conductors and insulators. So now we know that electric current cannot be passed through or cannot be flowed through all the materials. Some materials are there that can pass electric current, that allow the flow of electric current, and some cannot allow the flow of electric current. So on the basis of this, we can divide the materials in two parts, that is conductors and insulators. So conductors are the materials that allow electric current to flow through them. Means the material that allow electric current to pass through them or to flow through them, that materials, that substances are called conductors. As all metals are conductors of electricity. Alloys of metal, electrolyte, rainwater, human body, these are the conductors. Next one is insulators. So material that do not allow the flow of electric current through them, that materials are called insulators. Means these materials, these substances, they do not allow the flow of electric current through them. So the examples of insulators are distilled water, plastic, wood, paper, rubber, etc. These are the examples of insulators. Now students, here two activities are given. In first one, we are having an electric cell, conducting wires, and an electric bulb and a wooden block. And here we have to test that wood is an insulator or conductor. So first of all, we will arrange it like an electric circuit. When in the first diagram you can see, when the free end of the wire is connected to the bulb, that bulb is glowing. But when the wire is connected to the wooden block, this is the wooden block, in this case the bulb does not glow. Why? Because electricity cannot pass through this wooden block, because wooden block means wood is an insulator. In the next one, in this activity, here also you can see this is a simple circuit. Just as in this first one we have taken wood, here we have taken water in a container. So when electric current will pass through it, then electric current very easily it can pass through the tap water, and here your electric bulb will glow. It means that water is an electrical conductor. Now next topic of this chapter is chemical effects of electric current. In your previous class you have studied about heating effect and magnetic effect of electric current. Now you will study about chemical effects of electric current. So chemical effect of electric current, you have to study about electrolysis. So what is electrolysis? When an electric current is passed through a solution, that solution is an electrolyte, means solution should be electrolyte. Now what is electrolyte? Electrolyte is a solution. Suppose this is a solution. When in this solution electric current is passed, then very easily this solution can conduct electricity. And when electric current is passed through this solution, then it will undergo decomposition, means it will break into positive and negative ions. So this type of solution is called electrolyte. So when electric current is passed through an electrolyte, then it will split it or decomposed into positive and negative ions. Now what are ions? So ion is an atom or a molecule with an electric charge, and that charge may be positive charge or negative charge. Obviously these charges created by losing or gaining one or more electrons. Suppose we are taking examples of sodium, that is Na. So Na, it forms Na plus 1, means Na, sodium, it has one positive charge. So this is an ion. Okay, suppose we are talking about chlorine. So chlorine is Cl, it has one minus charge. Chlorine minus charge. So it is having negative charge. So these are the ions. Why sodium has a positive charge? Because sodium has lost one electron, and chlorine, it is having negative charge because chlorine has gained one electron. So ion is an atom or a molecule with electric charge, and that charge is created by losing or gaining one or more electrons. So these ions, means the negative ions are called anions, and positive ions are called cations. So these anions, means negative ions, they always get collected at the positive electrode, that is anode. Here you can see this is the positive electrode, that is anode, and the negative charges, they are attracted towards the positive terminal, that is the positive electrode, and the positive ions, that is cations, they get collected at the negative electrode, that is cathode. So this is the negative electrode. Why this is negative and why this is positive? Because you can see this is the cell, means an electric cell or battery is used here, as just we use in a circuit, just like that. So this electrode, it is attached to the positive terminal of the battery, that is why this is a positive terminal, which is called anode, and this is the negative electrode which is attached to the negative terminal of the battery, that is why it is the negative electrode, that is cathode. So when your electrolyte, on passing electric current, it breaks into positive and negative ion. Positive ions are called cations, negative ions are called anions. So positive ions will attract it towards the negative electrode, that is cathode, and your negative ions, means your anions, they will attract it towards the positive electrode, that is anode. So now we will study what is electrolysis. So when the process of decomposition of electrolyte solution, means when your electrolyte solution will decompose on passing electric current, so this process is called electrolysis, because this is an electrolyte solution. When electric current will pass through these electrodes, then what will happen? This electrolyte solution will break into, or it will dissociate or decompose into positive and negative charges, and this process is called electrolysis. And now the process of electrolysis, it is carried out in an apparatus, and the name of the apparatus is voltmeter or electrolytic cell. So this is the diagram of an electrolytic cell, where you can see it is made up of a glass vessel. This is a glass vessel or glass container where an electrolytic solution is present. So you can see this is the electrolyte, and here two metal plates. These two metal plates are called electrodes. So these two metal plates are present. One is attached with the positive terminal of the battery. This is the positive electrode, which is called as anode, and next one is the negative next one is attached with the negative terminal of the battery, which is called as cathode. So this is the diagram of an electrolytic cell. And now students, there is an activity where we have to show the process of electrolysis. So here aqueous copper sulfate solution, that is CuSO4 solution, is taken as an electrolyte. This is also an electrolyte because when electric current passes through it, then it is splitted or decomposed as positive ion and negative ion. So this is an electrolytic cell where CuSO4 means aqueous copper sulfate solution. Aqueous means copper sulfate solution is made, it is prepared with water. So here aqueous copper sulfate solution is kept in this electrolytic cell, and here you can see that two electrodes are also present, that is anode and cathode. They are present and they are attached to a battery. Okay, so when we take the aqueous copper sulfate solution in this voltmeter or in this electrolytic cell, and when electric current is passed through this aqueous copper sulfate solution, then what happen, CuSO4 means copper sulfate will break, it will dissociate as positive and negative ions. So copper means Cu will break as Cu plus 2, that is positive ion, it will make positive ion, and SO4, that is sulfate, it will break into SO4 minus 2, means sulfate ion. Okay, now what will happen, this copper sulfate solution, it is positive ion, that is why obviously it will move towards the cathode, that is the negative electrode, and this copper sulfate, it will move towards the anode. But one more thing, here water is also present, so electrolysis of water will also take place, and water is H2O, so it will break as H plus and OH minus. So here OH minus ion will also move towards that anode, means positively charged electrodes. Okay, so after some time, means when electric current is passed through this aqueous copper sulfate solution, then after some time we notice some bubbles which are formed at anode, means positive electrode, and when we test the gas which is evolved, means the bubbles, it contains gas. So when we test the gas which is released at anode with the help of a glowing splinter of wood, then it will glow more brightly. Why? Because this gas which is released, which is emitted or which is evolved at anode, that gas is oxygen. So you all know that oxygen supports burning. Okay, and one more thing, this copper, it will deposited at cathode. So this is the electrolysis of copper sulfate solution. Now next topic of this chapter is application of electrolysis. This process is very important because it is widely used for commercial purposes. So first use of this method is purification of metals. When metals are purified by the method of electrolysis, then it is called electro-refining. And for this purpose, when we have to purify the metals, what we do, we take the impure metal which has to be purified. That impure metal is taken as anode, and the pure metallic strip is taken as cathode, and the soluble salt of that pure metal is taken as an electrolyte. So here you can see, this is just for an example, this is the copper sulfate solution. Okay, it means that this impure metal is of copper. So here the impure metal is taken as anode, pure metal is taken, pure metallic strip, it is a thin strip which is taken as cathode, and soluble salt of pure metal is taken as electrolyte. So when electric current is passed through the anode, then what happened, this anode dissolves in the electrolytic solution, but only the pure metal, it moved towards the, obviously we know the metals, they make the positive ions, and cathode is the negatively charged electrode. So that metals, impure metals, when it will dissolve, anode will dissolve, then the pure metals only, they will move towards the cathode, and they get deposited on the cathode. So this is the purification of metals by the process of electrolysis. So by this process, so many metals are purified as copper, silver, gold, zinc, etc. Next process is extraction of metals from ores. So metals are extracted from the ores by using electrolysis. As for example, sodium, calcium, magnesium, etc. They are purified, they are extracted from their ores by the method of electrolysis. Now next application is electroplating. So electroplating is the process where a thin layer of one metal is deposited over the another metal, and generally the cheap metals are coated with precious metals like silver and gold just to make them look more attractive. And here what happened, the article to be electroplated is made the cathode. Here you can see silver spoon, it is cathode, and the metal which has to be deposited is made the anode. Here you can see gold plate, it is anode. And obviously the process is same as we have seen in the process of purification of metals. So again, gold chloride, it is taken as electrolytic solution. So same thing happened when electric current is passed through it, then the gold plate is dissolved and gold will deposited over the silver spoon, that is the cathode. It will deposited on the spoon means it will make a layer on the spoon. So this is the process of electroplating. Now what are the uses of electroplating, means what are the application of electroplating? So electroplating, it is widely used to prevent corrosion. For example, as on gas burner, bath taps, chromium plating is done. Next, jewelers, they used to electroplate silver and gold on less expensive metals. As we can see, the artificial jewelries, they are electroplated with silver or gold. Electroplating is also used to protect iron objects. Iron objects, we have to protect them from rusting. So we coat them by using zinc, that is you have studied about it, that is galvanization. So this is also an application of electroplating. And tin cans which are used to store the food items, it is also electroplated, means iron is electroplated with tin. So these are some of the applications of electroplating. Now your chapter is completed. Thank you, students.